Namaste students. In today's class, I'll be talking to you about TLC, that is thin layer chromatography, its principle, procedure and application. Chromatography, as we have seen in the last class, is a widely used technique to separate mixture of substances into their components. All forms of chromatography work on this principle. It has a stationary phase which may be a solid or liquid on a solid support. A mobile phase which may be a liquid or a gas flows through the stationary phase and carries the component of mixture with it. Different components travel at different rates, therefore are separated out. Thin layer chromatography does what it says. Using a thin layer of stationary phase, the components of the mixture are separated out. The stationary phase is the silica gel or alumina. The mobile phase is a liquid, solvent or a mixture of solvent. The TLC is a type of planar chromatography, the other being paper chromatography. Look at this picture. It has a beaker in which the solvent or mobile phase is poured. In this mobile phase, the TLC plate is kept and the analyte or the sample is placed on the stationary phase as a spot. The beaker is closed with a lid. As we have seen in the picture, TLC has three components: stationary phase, mobile phase and the TLC chamber. Stationary phase. The stationary phase is also called the TLC plate. It is stable and it is stable and it is chemically inert. A thin layer of the stationary phase is applied onto a surface layer which is inert. The layer should be of uniform thickness and it should have a very fine particle size. This layer of the TLC plate is prepared by mixing silica gel, which is also called the adsorbent, with an inert binder like calcium sulfate and water. This mixture is spread as a thick slurry on an unreactive sheet like glass, aluminum foil or plastic. The resultant plate is dried and activated by heating in an oven for 30 minutes at 110 degrees centigrade. The thickness of the absorbent layer is 0.1 to 0.25 millimeters. The mobile phase. The mobile phase is a solvent or a mixture of solvent. It must be pure, that is, it should not have any particles in it. It should be inert, that is, it should not react with the sample. These are the various mobile phases used in TLC. It should be noted that while using the mixture of solvents, these mixtures must be in a specific ratio. Now let us look at the TLC chamber. It is used for the development of the TLC plate, and it is used to maintain uniform environment inside the TLC chamber for proper development of the spots and to prevent evaporation of the solvents and to keep the process dust free. Excuse me. Now let us look at the procedure of the TLC. With a pencil, a thin mark is made at the bottom of the plate and the samples are spotted on this line at equal distances. The mobile phase is poured into the TLC chamber up to few centimeters from the bottom. Now the plate that was prepared is placed in the chamber and the lid is closed. This is how the entire procedure looks like. The mobile phase is allowed to sit for some time until the mobile phase reaches the edge of the plate. During this time, the components of the mixture separate out. The separated spots are now analyzed. These are analyzed by using different methods like fluorescent analytes, iodine vapors, or by specific color reagents, or by using potassium permanganate or bromine. After this process, the colorless spots can be now visualized as colored spots. Therefore, the spots can be seen. Now, as the spots are seen, that is, the spots are the components of the mixture are seen after the analysis, the RF value is calculated. The RF value is also called the retardation factor. It is used to, these RF values are compared with the known RF values of the known compounds so as to identify these compounds. The RF value is calculated by using this formula. The distance traveled by the components by the distance traveled by the solvent. The principle is similar to other chromatographic method. The separation depends on the relative affinities of the compounds towards either the stationary phase or the mobile phase. During this movement, the compounds with high affinity to the stationary phase attaches to the stationary phase and therefore moves very slowly. The others travel fast. Therefore, the separation is achieved. Excuse me. Various advantages of TLC is that it is a simple process. It takes less time. It is visualized very easily. The individual components can be identified. It helps in isolation. The process is faster. The purity of mixture can be assessed, and it is a cheap technique. The various applications of TLC is that the purity of the compounds can be checked. The identification of certain compounds like acids, alcohols, proteins, and antibiotics can be done. It is used to evaluate the reaction processes. It is used to purify certain samples. It is used for qualitative measurements, as it can be easily handled, inexpensive, and because of its rapid results, it is used widely in different labs. In the next class, I'll be talking to you about column chromatography. Thank you.